Let's go over another theorem in this video. We'll call it theorem 0.002. And this one won't come up often enough that we need a name for it in later videos. So we'll say that the theorem says that if the distance from a point P, so from a point P to a point Q is 0, then P equals Q. So we want to prove that this is true. And the way we're going to do that is by contradiction. So contradiction. First, let's say we suppose the distance from P to Q is 0. From P to Q is 0. And we also need to suppose that P does not equal Q. So suppose P is not equal to Q. And based off that, we want to arrive at some kind of contradiction. So since P is not equal to Q, then that by axiom 1, which is the point line incidence. So by point line incidence, there exists a line, and we'll call that line L, and it goes through P and Q, then by the ruler axiom, so by the ruler axiom, there exists a ruler. And that ruler is f of L to the real number. So basically there exists a distance. Also by the ruler axiom, ruler. Also by the ruler axiom, PQ equals f of Q minus f of P, and we take the absolute value of that. Since PQ equals 0, since PQ equals 0, then we say the f of Q minus f of P equals 0. So f of Q minus f of P equals 0. So f of Q minus f of P. So f of P equals 0, and f of Q equals f of P. But since not f of anything, just our function, since f is 1 to 1, so f is 1 to 1, then Q equals P. But this is a contradiction because we assumed that P does not equal Q. So that symbol right there means contradiction. This contradiction came from the assumption that P not equal Q. Therefore, P equals Q, and we are done.